Hello students, so we are doing revision. Okay, so we have done 1 mark questions, so more 1 mark questions will solve today also. Okay, if y equal to tan inverse e raised to 2x, then you have to show that dy by dx is equal to 2 upon e raised to 2x plus e raised to minus 2x. Okay, so here you have to find the derivative of this function. Y is tan inverse of e raised to 2x, so you can use derivative of tan inverse of x. So derivative of tan inverse of x is 1 upon 1 plus x square, right? So in place of x we have e raised to 2x square, and then the derivative of e raised to 2x, that is 2 e raised to 2x. Okay, now we can we want here 2, right? We don't want this term, so we can divide both numerator and denominator with e raised to 2x. So dividing numerator and denominator with e raised to 2x, you'll get, okay, I'll write here, okay, the whole term you are dividing, so you'll get 2 upon e raised to 2x, so 1 upon e raised to 2x plus e raised to 4x upon e raised to 2x, okay, which you can write it as 2 upon e raised to minus 2x plus this gets in the numerator, so e raised to 4x minus 2x e raised to 2x, and this is our required result. Okay, evaluate the integral. Okay, so this is a definite integral. You have to do, first you have to find the integral and then you have to substitute the limits. So integral of this you can write directly, that is log of 1 minus 3t, correct? And then the derivative of minus 3t, which is minus 3, gets divided. Okay, and the limits are from 0 to 4. Now substituting the limits, minus 1 upon 3 I can keep outside, so this is log 1 minus 3 into 4, 12, minus log of 1 minus 0, so log of 1. Okay, so this is minus 1 upon 3 log of minus 11 minus log of 1. So log of 1 is 0, so this will be log of minus 11 upon minus 3. Okay, so you have to integrate this term. So looking at the numerator and the denominator, let's substitute x raised to e minus e raised to x as t. Okay, so its derivative is x raised to e is e x raised to e minus e raised to x. Okay, so this is dx. So we can write this term, okay, if you take out e from this, you will get this will be e raised to e minus 1. Okay, x e raised e minus 1 minus e raised to x upon e, right? So this we can write it as e into x raised to e minus 1 minus e raised to x minus 1, and this is nothing but our numerator. Okay, so substituting in the integral, you will get integral, this term will be dt upon e, right? T e. So you can take out 1 upon e. Integral of this is log of t plus c. So substituting your value of t, which is x raised to e minus e raised to x, plus c. Okay. Next question is, if alpha, beta, gamma are the angles which line makes with the positive axis, you have to find a sin square alpha plus sin square beta plus sin square gamma. So whenever this question is from 3D geometry, that is we know that sum of the direction cosines, that is cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, we know this condition. So alpha, beta, gamma are the angles, okay, with the direction of the positive axis. A line makes with the positive axis. So using this, we have to find sin square alpha plus sin square beta plus sin square gamma. Now when you take sin square alpha plus sin square beta plus sin square gamma, okay, how you can write this sign in terms of cos? Using the identity, right? So sin square alpha, I can write it as 1 minus cos square alpha, then 1 minus sin square beta, cos square beta, sorry, plus 1 minus cos square gamma. Okay, so 1 plus 1 plus 1 becomes 3, and minus we have cos square alpha plus cos square beta plus cos square gamma. Now these three terms add up together, which gives you 1. So the final answer is 2. Okay. So here you have to find the value of this determinant. Okay. So using the determinant, you will get sine 10 degree cos 80 degree minus sine 80 degree into cos 10 degree. Okay, so this becomes sine 10 degree cos 80 degree plus sine 80 degree cos 10 degree. If you can remember, this is your trigonometric identity, that is sine a plus b. Okay, here a is 10, b is 80. So we can use sine a plus b. So sine 90, which is 1. Okay. Here y is given, that is sine inverse root of 1 minus x square 10 sine inverse of x. So you can substitute, okay, in place of sine inverse, that is let's say sine inverse of x, you can take it as theta. Okay, so your x is sine theta. Okay, so substituting over there, you will get y equal to sine inverse root of 1 minus x square 10 sine inverse of x is theta. Okay, now using this, you can find tan theta using the triangle method. So your sine theta is x, that is x upon 1. So this term will be what? Root of 1 minus x square, right? So your tan theta will be adjacent, that is root of 1 minus x square upon x. Correct? So your tan inverse of this, yeah, right. So you can take this as, substitute x equal to root of 1 minus x square upon tan theta. Okay, so you can substitute root of 1 minus x square as x tan theta. This you can write it as upon x. You can substitute here. This I have written wrong. Right. Tan is opposite upon adjacent. So x upon root of 1 minus x square. Okay. So in place of tan theta, you can substitute here x upon root of 1 minus x square. Okay. So this will be this. So y equal to sine inverse. Now you can substitute here x equal to sine theta. Okay. Yeah. So this will be your, or you can directly write. You'll directly get sine inverse of x. Okay. Now you can find a dy by dx. So dy by dx is 1 upon root of 1 minus x square. Okay. Next question, here f of x is given, that is function is given, cot inverse of root of cos 2x. Okay, and you have to find its derivative at pi by 6. So its derivative f of x, I can write it as cot inverse. Now this is under root is given, so its derivative is, cot inverse derivative is minus 1 upon 1 plus x square. Okay, and then the derivative of cos 2x, which is minus sine 2x, and then the derivative of, you have to use the chain rule here, 2x, which is 2. Okay, so minus into minus, it becomes plus. So this will be 2 sine 2x upon 1 plus cos 2x. Okay, now at the point pi by 6, which is 30 degree, so 2 into sine 2 into pi by 6 upon 1 plus cos 2 pi by 6. So this will be pi by 3. So 2 into sine 60, which is root 3 by 2 upon 1 plus cos 60, which is half. So you will get root 3 upon 3 by 2. So final answer is 2 root 3 upon 3. Okay. So here y is given, and you have to show that x d square y by dx square is equal to dy by dx. Okay. First we'll find out the derivatives. So first derivative, that is dy by dx, is 0 plus 2bx. Okay. Then its double derivative is 2b. Okay. Now we have to form this in this form. Okay. So dy by dx, we have 2bx, which we can write it as x, I'll take here, so it will be 1 by x dy by dx equal to 2b. So 2b we have equal to this, so we are getting the result. This is 1 by x dy by dx. Okay, this is the desired result. Let's solve this. So this matrix you have to multiply with this matrix and then you have to add it with this. Okay, so multiplication row into column. So 7 3s are 21. First you should know what order it will be. So this is 2 cross 3 and this is 3 cross 1. So you will get the order 2 cross 1. Okay, so 2 rows and 1 column you will get. 21 plus 4 plus 10, then row column 27 plus 1 into 5 5. Okay, then here I'll take this 2 inside, it gets multiplied inside. 8 4, so adding you will get 31 plus 4 34, 13, so 40. So adding you will get 42 44. So this is the answer. Okay, this is 35, this is 43. Okay, so you have to integrate this function log x dx. So you can use here integration by parts. Okay, now we know that late, so log function comes first. So you have to consider log function as the u function into 1 dx. So this becomes your u function, this is v. So integration by parts, u integral of v minus integral derivative of u into integral of v okay, integral of 1 is x minus derivative of this is 1 by x, integral of this is x dx. So x log x minus integral of 1 is x plus c. This is the answer.